The James Webb Space Telescope has just achieved a historic milestone by capturing the first ever real and authentic image of Oumuamua. Although this enigmatic interstellar object was first discovered by scientists in 2017, there were a lot of doubts about whether the picture obtained at that time was enough to tell us everything we ought to know about this strange visitor. But now, a significant breakthrough has offered new insights with an exclusive image captured by JWST. How relevant is this discovery to scientists, and what new details does it reveal? Join us as we look into the terrifying objects in space that the James Webb Telescope has revealed. Oumuamua is the first confirmed object from another star to visit our solar system. This interstellar visitor looks like a rocky, cigar-shaped object with a reddish tint. The discoverers named it Oumuamua, which means a messenger from afar arriving first in Hawaiian. Oumuamua is up to a quarter mile, 400 meters, long and very elongated, about 10 times longer than it is wide. This aspect ratio is greater than any asteroid or comet observed in our solar system so far. While its stretched-out shape is surprising and different from objects in our solar system, it could offer new insights into how other solar systems formed. The observations suggest that this unusual object has been drifting through the Milky Way, not bound to any star system, for hundreds of millions of years before its unexpected encounter with our solar system. But how exactly was Oumuamua found? Stay tuned because the most shocking part is yet to come. On October 19, 2017, a strange object named Oumuamua was detected speeding through our solar system. This asteroid had been traveling for over a century before it was finally identified. It reached a significant cosmic milestone in 1837, but astronomers missed it. Oumuamua would continue its journey through our solar system for several decades at a steady speed, and astronomers and telescopes failed to detect it. It wasn't until 2017 that Robert Warwick, a scientist at the University of Hawaii, noticed a faint elongated streak in the sky captured by the Pan-STARRS 1 telescope, revealing a fast-moving object unlike any seen before. Initially, scientists thought Oumuamua was a comet because of its unusual behavior, but they later identified it as an asteroid, a small rocky object usually found in the asteroid belt between Mars and Jupiter. However, further observations showed that Oumuamua was moving away from the Sun at an unusual rate, deepening the mystery. The lack of visible outgassing, which typically occurs in comets, puzzled scientists as the object accelerated in a way that defied predictions, leading them to question whether it was truly an asteroid or a comet. One of the most remarkable features of Oumuamua was its consistent brightening and dimming every 7.3 hours, indicating that it was tumbling and most likely spinning around its shorter axis. Such speed suggested that Oumuamua was a solid object with a stronger and more durable composition than most comets, which are typically loose and fragile. Its dark red color, similar to that of moons in the outer solar system, showed that it had been exposed to cosmic radiation for millions of years, altering its surface. As experts analyzed the data, suspicions about the true nature of Oumuamua began to surface. Some speculated that it might be an advanced extraterrestrial probe or a defunct alien spacecraft, while others considered more likely possibilities, such as a previously unknown type of comet or asteroid. Even more conservative theories suggest that Oumuamua is a remnant of an exoplanet that was ejected during a catastrophic event in another star system. There is still no consensus on what Oumuamua actually is. Predicting Oumuamua's future path has proven difficult because it has already started to move away from the Sun, exiting our solar system at a sharp angle. Current estimates suggest that Oumuamua is returning to interstellar space, where it will continue its lonely journey across the universe. The discovery of Oumuamua sparked intense debate and interest among astronomers, scientists, and the general public. This unusual cosmic object, the first of its kind ever found, inspired a flood of theories trying to explain its origins and nature. Was it just a regular cosmic object, or could it have been an alien probe sent to explore our solar system? Let's look deeper into the various theories and evidence that have emerged in the effort to understand the mystery of Oumuamua. Because of the various data that was gathered, theories concerning Oumuamua evolved. Some experts suggested that Oumuamua might be filled with gas, which could explain its sudden acceleration as it moved away from the Sun. Then came the shocking suggestion that it might not be a natural object at all, but rather an alien spacecraft. The unusual properties of Oumuamua, particularly its non-gravitational acceleration, support this idea. Typically, comets accelerate due to outgassing, the release of gas and dust as they approach the Sun and heat up, but no such outgassing was observed with Oumuamua. Therefore, some researchers began to consider more unconventional ideas. Could this be a probe sent by an extraterrestrial civilization to investigate Earth? Although this sounds like science fiction for those who believe in the possibility of extraterrestrial life, it is one of the most fascinating ideas. Dr. Michio Kaku, a well-known theoretical physicist, suggested that Oumuamua was ejected from a distant star during a supernova explosion. According to billionaire entrepreneur Elon Musk, the object might have formed when two celestial bodies collided and melted, resulting in its unique hybrid shape. Initially, astronomers were excited to find that Oumuamua's trajectory appeared to be aligned with Vega, the brightest star in the Lyra constellation, known for its debris disk. Calculations suggested that Oumuamua might have taken about 600,000 years to reach its current position from Vega. However, this theory quickly fell apart when it became clear that Oumuamua's path had changed during its journey. Astronomers concluded that it must have passed close to a new star system before entering our solar system. Its speed was similar to that of nearby stars, increasing the likelihood that Oumuamua had been traveling through the Milky Way for billions of years before crossing paths with our solar system. Another interesting theory suggests that Oumuamua is a piece of nitrogen ice. Researchers Alan Jackson and Stephen Desch of Arizona State University proposed that it could be debris blown off a Pluto-like object by a massive impact. For this theory to hold, Oumuamua would have to be much smaller than previously thought. Despite this, the nitrogen ice theory has gained traction, since it can explain both the object's composition and its unusual acceleration. One of the most significant discoveries made shortly after Oumuamua's detection was that it was traveling in a hyperbolic orbit, a boomerang-shaped trajectory that strongly indicated it was not native to our solar system. Instead, it was just passing through and would never return. This revelation led to speculation about its future visibility, with many believing that Oumuamua would disappear into space, never to be seen again. But Oumuamua would defy all odds and prove most theories wrong. The object's behavior defied expectations. One particularly notable feature was its unexpected increase in speed as it approached the Sun. While gravitational forces from large celestial bodies like planets and stars can speed up smaller objects such as comets and asteroids, they couldn't fully explain Oumuamua's acceleration. The object's speed reached 54 meters per second, 87 kilometers per second, about 3 times that of the average comet in our solar system. This anomaly prompted experts to reconsider their initial classification of the object as an asteroid, leading many to speculate that it might actually be a comet. Recently, Jennifer Bergner, a chemistry professor at the University of California, Berkeley, and Daryl Seligman, a postdoctoral fellow at Cornell University, suggested a new explanation. They proposed that Oumuamua's acceleration could be due to outgassing driven by unfamiliar processes occurring outside our solar system. According to their theory, while Oumuamua traveled through interstellar space, it was exposed to cosmic radiation. This radiation might have released stored hydrogen trapped in the object's icy structure. When Oumuamua entered the solar system and warmed up, this hydrogen could have been released, providing the force needed to explain its acceleration. Their calculations indicated that the outgassing of hydrogen might account for Oumuamua's movement. Decades of experiments support their idea that high-energy cosmic rays can break hydrogen molecules from water ice, storing it within an object. Seligman claimed this explanation is simpler and more plausible than previous, more speculative theories such as Oumuamua being made of hydrogen ice or some exotic material. However, not all scientists agree. Harvard scientist Avi Loeb, who had previously suggested Oumuamua might be an alien spacecraft, disagrees with Bergner and Seligman's hypothesis. Loeb argued that they overestimated the amount of hydrogen Oumuamua could contain due to an error in their temperature calculations. According to Loeb, there wouldn't have been enough hydrogen to cause the observed acceleration, leaving the mystery unresolved. With Oumuamua now out of reach, we may never know its true nature or chemical composition. However, Seligman remains hopeful that more interstellar objects will be discovered soon, giving astronomers more chances to study these visitors. The next generation of telescopes, expected to be operational within the next decade, could greatly advance this research and help answer questions about interstellar objects. As scientists debated Oumuamua's origins and behavior, they encountered a new surprise: the possibility that Oumuamua isn't alone. Recent findings suggest it might have a companion interstellar object. This discovery raises new questions. Dr. Bannister suggested that the object might still have particles that are affecting its velocity, adding to the mystery. Astronomers struggled to detect the usual signs of outgassing, such as cyanogen, gas which is often found in comets. Despite thorough searches, no gas emissions were detected. This suggests that Oumuamua could be chemically unique compared to any comet in our solar system. In an attempt to gather more information about the object's composition, researchers tracked it for over 30 hours using the Spitzer Space Telescope. Yet their efforts yielded no clear answers. The lack of thermal emissions and obvious gas made it even harder to classify Oumuamua. Some scientists suggested that Oumuamua might be more reflective than initially thought if it showed thermal characteristics similar to those of a comet, but these details remain unclear. An object's reflectivity or albedo can provide clues about its size, composition, and surface features. Although much has been learned about Oumuamua, no one has definitively identified what it is. It remains a unique and mysterious interstellar visitor that challenges our understanding of celestial objects and raises more questions than answers. Some have wondered if Oumuamua might be something more extraordinary or even a potential threat, given its erratic movement and the lack of hard data. Although some speculative theories recently suggested it could be on a collision course with Earth in the coming weeks, most data refutes these predictions. About 6 months before Oumuamua's close encounter with Earth, a small interstellar meteor about 3.1 meters in size crashed onto our planet. Although it had no clear connection to Oumuamua, Avi Loeb took an interest in this meteor known as IM2. Loeb speculated that an artificial interstellar object could act as a parent craft, releasing several small probes as it passed near Earth. In a draft research paper, Loeb and Sean Kirkpatrick, director of the Pentagon's All-Domain Anomaly Resolution Office, ARO, explored this idea, which ties into the government's term for UFOs, Unidentified Anomalous Phenomena (UAP). Their theory suggests that these probes could be expelled from a larger vessel by natural forces such as solar radiation or gravitational pressures from the sun due to their small size and limited reflection of sunlight. These dandelion seed probes, as Loeb called them, might go unnoticed by our telescopes. These tiny probes could then approach Earth's atmosphere using specialized technology that allows them to slow down and avoid burning up, possibly even landing safely using parachute-like structures. Loeb's hypotheses focus on the possibility that extraterrestrial civilizations might be interested in studying rocky planets with atmospheres, such as Earth, Mars, and Venus. Such planets would naturally attract the curiosity of intelligent life forms who might have launched exploratory probes long before humans began exploring space. In this scenario, the probes might not be in constant communication with the mothership and could have become lost or inactive over time. Loeb likened this idea to checking a mailbox for letters from someone who may no longer be alive, suggesting that the probes could continue their mission even if the civilization that created them no longer exists. Loeb has faced significant skepticism from the scientific community since he first suggested in 2018 that Oumuamua could be an alien spacecraft. Many researchers argue that his idea is purely theoretical and lacks strong evidence. In 2021, a letter published in the journal Astronomy and Astrophysics dismissed the possibility of interstellar travel, citing the immense cosmic timescales required to travel between stars. The letter's authors concluded that Oumuamua was more likely a naturally occurring object, possibly an oddly shaped rock, rather than an intentional probe by an alien civilization. Other studies have supported this natural explanation, pointing to hydrogen outgassing as the most likely cause of Oumuamua's unusual acceleration. Researchers published findings on March 22, 2023, indicating that as Oumuamua passed through the inner solar system, it likely released hydrogen trapped within its frozen body, mimicking propulsion from an unidentified source. Despite these explanations, the Pentagon has intensified its investigation into unexplained aerial phenomena within U.S. airspace. Since its establishment, the All-Domain Anomaly Resolution Office has initiated over 360 new investigations into reported encounters with unidentified objects involving U.S. military personnel. About half of these cases have been linked to balloons or other objects, while the other half remain unresolved due to insufficient data. To solve the mysteries of interstellar space and investigate objects like Oumuamua, humanity needs to gain a deeper understanding of dark energy and other cosmic phenomena. The idea of sending a spacecraft to chase after this mysterious object is exciting, but it presents significant challenges. For example, Oumuamua, which is moving at incredible speeds, will pass beyond Saturn's orbit in just 2 years, with a hyperbolic excess velocity of $5 per year. The mission to pursue Oumuamua is unlike anything humanity has ever attempted. Even our fastest spacecraft cannot match these speeds. So, what kind of vessel could carry out such a mission? Should we rely on advanced technologies like solar sails, or should we explore more speculative propulsion techniques such as wormholes? As we consider these technological challenges, it's important to recognize that humans are unique among Earth's species in their desire to explore space. Most animals on Earth, from birds to reptiles to fish, have no concern for what lies beyond their immediate surroundings. Even among sentient species like whales, the idea of space exploration or communication with extraterrestrial beings is entirely foreign. This raises an interesting question. If Earth's intelligent species largely ignore space, what does this imply about potential extraterrestrial civilizations? Could they be oblivious to the larger cosmos, much like most creatures on Earth? The Fermi paradox highlights the conflict between the high probability of extraterrestrial civilizations existing and our complete lack of evidence for them. With over 400 billion stars in our galaxy, many of which are expected to have habitable planets, it's reasonable to expect intelligent life to arise elsewhere and develop interstellar travel technologies. Given that many stars are billions of years older than our Sun, these civilizations should be far ahead of us. However, we have found no strong evidence of their existence. The Fermi paradox states that extraterrestrials should exist and be capable of interstellar travel, but we have had no clear contact with them. This seeming paradox has led some to suggest that our search efforts are futile and that resources should be redirected elsewhere. Critics argue that unless extraterrestrials make themselves known, there is little reason to continue funding research like the search for extraterrestrial intelligence, SETI. The paradox is named after physicist Enrico Fermi, who launched this line of inquiry with his famous question, "Where is everybody?" This paradox challenges our assumption that if extraterrestrial civilizations exist, they would seek to communicate with us. It suggests that either we are the only intelligent species in the galaxy or that these civilizations deliberately avoid contact for unknown reasons. Scientists have proposed several possible explanations for the Fermi paradox. One theory, known as the Great Filter, suggests that certain crucial steps in the evolution of life are so difficult that very few planets reach the point of hosting intelligent civilizations capable of space travel. This could explain why, despite the vast number of stars and planets in the galaxy, intelligent life seems so rare. Another possibility is that advanced civilizations may destroy themselves before achieving long-term space travel due to technological or environmental catastrophes. Alternatively, they might be observing us from a distance, waiting for humanity to develop a certain level of maturity before making contact. Whatever the explanation, the Fermi paradox challenges us to rethink our assumptions about extraterrestrial life. Perhaps we should focus on better understanding ourselves and our place in the universe before seeking contact with other species. Alternatively, we could redouble our efforts to find signs of extraterrestrial civilizations using new technologies and methods to search the vast expanse of space.